In the theory of semiconductor physics, there are mainly two types of band gaps material are present. But before we start, let me tell you, today the topic we are dealing with is direct or indirect band gap semiconductor. I was saying there are two types of band gap materials are present in the theory of semiconductor. And depending on their energy and crystal momentum present in the crystal, and furthermore, they can be divided into two categories, namely direct band semiconductor and indirect band semiconductor. Look at this image. Let's say the number of atoms in a molecule is increased. Then the splitting of atomic orbital takes place and it splits the atomic orbital into multiple levels. And once they come together, they form bands. In other words, mixing of atomic orbital will result in formation of a band. This picture shows the formation of band for metal and semiconductor materials. Follow this picture. Here, the bonding orbitals and the anti-bonding orbitals are present. The attractive interaction between the orbitals of two or more atoms is termed as bonding orbitals. Electrons are considered to move in form of waves, and if more than one wave comes closer in this phase, the result will be a stable state of wave within the crystal. Look at the periodic arrangements of the atoms within the crystal and the electronic orbitals of the adjacent atoms. After the formation of electronics bonding, the adjacent hybrid orbital starts to interact. At the end, when the formation of valence band and the conduction band is done, the band gap occurs. We have plotted E against wave vector k, and this entire structure is called crystal band structure. This structure is a EK diagram for a direct band gap semiconductor. This diagram corresponds to this figure. What we can find out in this is that the position of conduction band, valence band and the band gap. We know it is the first Brillouin zone structure of a crystal, and in the first Brillouin zone, the boundary is k is equal to minus pi by a to pi by a. And here minus pi by a to pi by a area. Direct band gap and indirect band gaps. Let us consider the first Brillouin zone boundary. And if it is seen that the maximum energy level of the valence band or the peak of the valence band and the minimum energy of the conduction band occurs at the same wave vector or the momentum, then it is called the direct band gap semiconductor. For example, gallium arsenide, indium arsenide. When the maximum energy of a valence band occurs at a different wave vector to the minimum of the conduction band, it is called indirect band gap semiconductor. To excite an electron from valence band to conduction band, phonon and assistance is required here for conservation of electron momentum. For example, silicon, germanium, etc. First Brillouin zone boundary in the crystal. Schematic band diagram of semiconductor plotted along the three direction in the reciprocal space lattice. That was direct band gap and indirect band gap, or DBG and IBG. And with this, we come to an end of this session. And today, we learned mixing of atomic orbitals and band formation, the first Brillouin zone in the crystal, and lastly, the direct band gap and the indirect band gap. We will meet again with another interesting topic of electronics. Have a nice day. Revise again. Bye bye.